Okay, we'll carry on now. The whole idea of independence is a really important one in both probability and statistics, and again there will be questions asking about independent events and so on. And independent means that the occurrence of one event is not affected by the occurrence of the other. And so, for example, you have something like a customer has a child with them and purchases 2 items. Those are 2 different events that are probably independent. Okay, we don't know for sure if they're independent, but you could think, well, it's probably not going to be linked. Dependent is where the occurrence of one is affected by the occurrence of the other. For example, a person is a heavy drinker and a heavy smoker. This has been shown to be related. So the probability of someone being a heavy smoker is actually increased if they are a heavy drinker and vice versa. And that is one of the things that statistics does, is it looks at how often these 2 things occur together and looks at how often that would happen by chance and uses that to decide whether there is some relationship between those 2 phenomena, like drinking and smoking or buying 2 items and having children with you or whatever. So the whole idea of independence is an absolutely key one to probability and statistics. So we're going to just work at a reasonably basic level in this part of the course, where we're going to be talking about conditional probability and the idea of independence, but we're only going to be working from tables, which makes it a lot simpler. Okay, we've got here, the printed and categorises the jobs received over the last month as urgent or not urgent and small or large. So they've got stuff coming in and they're going to decide, okay, big jobs, small jobs, large jobs, urgent, non-urgent. And they want to know, interested to know really, is the relationship between big and small and so on the same? Okay, so a new job arrives based on past information. So we a priori, relative frequency or subjective here? Relative frequency, because it's based on past information. Because we're talking here about a new job. So we're using relative frequency. If I had said he's going to take a job at random out of the ones he already has, that would be a priori. But because we're not talking about these jobs, we're talking about a new job and we're based on historical evidence, that's why it's relative frequency. Okay, so what is the probability that it's small? Okay, the probability that it's small equals 450, which is the number of small jobs, divided by 750, which is a total, which comes to 0.6. Okay, urgent. The probability that job is urgent equals 350 over 750, which comes to 0.47. Okay, everyone happy with that so far? Okay, and then the next one is, what is the probability that it is a large job and urgent? Okay, how many of the jobs are large and urgent? 200. Large and urgent, 200. Where the 2 intercept? Okay, so 200, so probability equals, probability of that equals 200 divided by 750, which equals 0.27. So what you do is you look at how many ways can that be true. There are only 200 ways that can be true out of the total possibilities. Okay, so that's basic stuff without conditional. Now we're coming on to